At the very edge of our solar system, where sunlight fades into a dim, distant glow, there exists a world that defies everything we thought we knew. A world that was once called a planet, then stripped of its title and forgotten by many. A world so distant that for nearly a century, it remained nothing more than a blur in our telescopes. Silent, frozen, unchanging, or so we believed. But hidden beneath that faint point of light was a story waiting to be told. A story of motion, of change, of a world that is far more alive than anyone ever imagined. In 2015, humanity sent a messenger into the darkness, a spacecraft built by NASA, traveling billions of kilometers across the emptiness of space. Its destination, a world no human eyes had ever truly seen. When New Horizons finally arrived, what it revealed shocked the world. Towering mountains of ice, glaciers flowing like rivers, a glowing atmosphere stretching into space. This was not a dead world, this was something else. And now, with the powerful vision of the James Webb Space Telescope, we are beginning to uncover even deeper secrets. This is the story of Pluto, the most mysterious world in our solar system. The story of Pluto begins not in space, but on Earth. In 1930, at the Lowell Observatory in Arizona, a young astronomer named Clyde Tombaugh was searching for something no one had ever seen before. Astronomers believed there was a hidden planet beyond Neptune, a world whose gravity might explain strange irregularities in the orbits of the outer planets. Night after night, Tombaugh scanned the sky using a device called a blink comparator, comparing photographic plates taken days apart. Most of the stars remained fixed, but one small point of light moved. That tiny motion changed everything. That object was Pluto. At first, it was celebrated as the long-lost ninth planet, a distant member of our solar system, orbiting far beyond Neptune. But from the very beginning, Pluto was different. Its orbit was strange, highly elliptical, and tilted compared to the other planets. Its brightness varied unpredictably, and its size was unknown. For decades, Pluto remained a mystery. Even the most powerful telescopes could not resolve its surface. To scientists, it was nothing more than a pixel, a world without detail, a world without answers. As the 20th century came to an end, a new discovery began to reshape our understanding of the outer solar system. Astronomers started finding more objects beyond Neptune. Hundreds, then thousands, of icy bodies orbiting in a vast region known as the Kuiper Belt. These objects were ancient, remnants from the formation of the solar system over 4.5 billion years ago. Among them were worlds similar to Pluto. And then, in 2005, astronomers discovered Eris, a world comparable in size to Pluto. This discovery forced a difficult question. If Pluto is a planet, then what about Eris? And what about the countless other objects in the Kuiper Belt? The answer came in 2006, when the International Astronomical Union redefined the meaning of the word planet. Pluto no longer qualified. It was reclassified as a dwarf planet. To the public, it felt like a demotion, but scientifically, it was a revelation. Pluto was not an outlier. It was part of a vast population of icy worlds, a new frontier in our solar system. For decades, Pluto remained beyond our reach. Too far, too cold, too mysterious. But scientists knew that to truly understand Pluto, they had to go there. In January 2006, NASA launched one of its most ambitious missions, a spacecraft named New Horizons. It was small, about the size of a piano, but it carried humanity's curiosity across billions of kilometers of space. Its journey would take nearly a decade. Along the way, it passed Jupiter, using its gravity to gain speed before continuing outward into the outer solar system. On July 14, 2015, after traveling for nearly a decade across space, the spacecraft New Horizons reached Pluto. For a few hours, it observed the surface and captured hundreds of images while moving past the planet at over 50,000 kilometers per hour. These images were transmitted back to Earth across billions of kilometers. When scientists received the data, it became clear that Pluto was not a frozen, inactive world as previously believed. Instead, it showed clear signs of geological activity, which was unexpected for a small and distant object in the outer solar system. One of the most prominent features was a large, bright, heart-shaped region known as Tombaugh Regio, named after Clyde Tombaugh. Within this region lies Sputnik Planitia, a vast basin more than 1,000 kilometers wide, composed primarily of nitrogen ice. At Pluto's extremely low temperatures, this ice can slowly flow over long periods through convection, forming polygon-shaped patterns where warmer ice rises and cooler ice sinks. This indicates that the surface is continuously being renewed. Another key observation was the very low number of impact craters in this region, suggesting that the surface is relatively young in geological terms. This raised an important question about how such a distant world can remain active. As more data from New Horizons was analyzed, additional features were identified, including mountain ranges with peaks reaching 3 to 4 kilometers in height. These mountains are composed of water ice, which behaves like solid rock at temperatures around -220 degrees Celsius. Examples include Hillary Montes and Tenzing Montes, indicating strong geological processes. Further observations revealed large dome-shaped structures such as Wright Mons and Picard Mons, which are interpreted as possible cryovolcanoes. These features likely formed through the eruption of water, ammonia, and other volatile materials from Pluto's interior, suggesting the presence of an internal heat source. Scientists have also found evidence that Pluto may contain a subsurface ocean beneath its icy crust. This ocean could remain liquid due to internal heat, radioactive decay, and antifreeze compounds like ammonia. Supporting evidence includes the structure of Sputnik Planitia and the reorientation of Pluto's surface, indicating a mobile layer beneath the crust. Pluto also has a complex atmosphere extending hundreds of kilometers above its surface, composed mainly of nitrogen with traces of methane and carbon monoxide. Sunlight interacting with methane produces layered haze made of complex organic molecules, which scatter light and give Pluto a blue appearance when viewed from behind. This atmosphere changes over time as surface ices sublimate into gas and later refreeze depending on Pluto's distance from the Sun. Years after the flyby of New Horizons, new insights into Pluto have been obtained using the James Webb Space Telescope, which operates in the infrared range and can detect heat and chemical signatures not visible in ordinary light. Observations from JWST show that Pluto's atmospheric haze absorbs solar energy and re-emits it into space, producing a cooling effect that lowers atmospheric temperatures more than expected. These discoveries have fundamentally changed our understanding of Pluto. What was once considered a distant and inactive world is now known to be complex, dynamic, and still evolving. From flowing nitrogen ice and towering water ice mountains to possible cryovolcanoes and a subsurface ocean, Pluto demonstrates that geological activity is not limited to large planets. Its atmosphere, shaped by long-term physical and chemical processes, and recent observations from the James Webb Space Telescope further highlight how unique this world truly is. Even at the outer edge of the solar system, Pluto continues to challenge scientific assumptions and expand our understanding of planetary systems. As new observations and future missions are developed, this distant world may reveal even more about the formation and evolution of planets. This is Cosmic Explorer. Subscribe and join us as we explore the universe, one discovery at a time.